Hi, everybody. My name is Shivam Gupta.
And I am Nadia Asgaf. We are from SCM class of 2026, and this is our capstone on flower network optimization. The master plan is for our sponsor organization's wheat import and distribution network in Latin America.
Motivation and background. The sponsor organization runs a port-centric wheat supply chain that supports a $3 billion business. The network is under pressure for four main reasons. One, they're at near max capacity, and demand is still projected to grow by about 16% over the next 5 years. The flower business is also low margin, so logistics efficiency obviously matters. The system is also exposed to constant disruptions, such as port strikes, floods, and landslides.
For the network overview, the wheat network has five main stages, which are ports, mills, distribution center, and customers, with the interim warehouses used when wheat needs temporary storage before the milling process. This creates multiple routing options and operational trade-offs across the network.
For the problem we are solving, there are some core unique challenges that pose additional complexity. Firstly, this is a high-dimensional network with many nodes and possible flows. So there are 3 ports, 5 mills, 7 interim warehouses, 13 distribution centers, and 1,200 customers. Secondly, there's a structural network fragility. 75% of the volume of the wheat flows to the country via Port A, which creates a single point of failure where localized disruptions, such as port strikes, would sever supply for a big portion of the business. Thirdly, there are some volatile transportation costs in the data, and these are referred to in dollars per ton kilometer. So the rates fluctuate by up to 24% between seasons and by 3 to 5 times between regions, such as coastal versus mountain areas. And this makes using static averages for the transportation costs more difficult. In terms of the data and evidence that we're using for the project, we are using sponsor-provided datasets, which includes information on their owned sites, such as mills, interim warehouses, DCs, customer master information like customer location, demand information on those customers and the demand forecast for the next 5 years, as well as cost information such as freight costs, production costs, and inventory holding information. So first we obtain the data, validate and clean the data, and then we analyze, do some statistical analysis to understand what are the current flows and what may be the opportunity areas to generate savings via the network redesign project. Our guiding question is, how can the supply chain be redesigned to minimize OPEX and CAPEX while increasing resilience without lowering service levels?
For the methodology, we model the network using a mixed integer linear programming with the formulation and solve it in the Python with Gurobi, and the model minimize the total cost, transportation, handling, inventory, and selected CAPEX while enforcing constraint for capacity, flow balance, and service requirements. Binary variables here allow investment and network configuration decisions to be tested whether or not to open or utilize the mills, interims, and distribution center. For the scenario analysis, we run scenarios such as brownfields expansion versus new facilities or greenfield, and stress test for changes in demand and logistic costs to evaluate how robust the solution is under disruption risk. For the expected contribution, for the sponsor, the output is a 5-year CAPEX roadmap and lower OPEX through optimized flows. And more broadly, the project provides an emerging market network design framework and a practical way to embed resilience into MILP optimization. Thank you for watching.